Okay, everyone, so today we're looking at how to prepare a solution. So if we want to make an aqueous solution, how can we go ahead and actually do it? So there's actually two ways that we can prepare a solution. So we're going to go through both. So one is to prepare what's called a standard solution. So the term standard solution is actually any solution that you know the exact concentration of. Which is what? So a standard solution is a solution for which the precise concentration is known. So if I know I have a 1.0 mole per liter solution of hydrochloric acid, this can be called a standard solution because I know the concentration of it. To make a standard solution as accurately as possible, we have to use a flask, and I just finished writing all over it, but we have to use a flask known as a volumetric flask. So that's what this picture here is showing you. So a volumetric flask is a very exact measurement of volume, and it actually only has one measurement line on it. So this line is exactly to the point that measures the amount that the flask was built for. So for example, of course, the bottom of the meniscus is where we would read that line. So this flask in particular makes 500 milliliters of solution, and that's actually the only amount that this flask can make. If we wanted to make more or less, we would have to use a different flask. So they have ones in all kinds of sizes that you can purchase. So there's smaller ones, 250 milliliter, a 100 milliliter, and there's even larger ones, 1 liter, 2 liter volumetric flasks. So how we can do this, how can we make a standard solution, is two ways, as I mentioned. So we can use it from, or we can make one from a solid solute and dissolve it in water, or we can use a stock solution, which we're going to talk about later on. So for now, for this first point, we're going to look at how to do it from a solid solute. Okay, so in order to prepare a solution from a solid solute, you actually already know how to do the calculations to this because they're exactly the same as when you did the molar concentration calculations. So the first thing we would do, so physically, like how would we go about making the solution? So you would have to determine first what mass of solute will you need to weigh out. And of course, this is going to depend on what your volume is and what concentration is that we want to create. So you'd have to solve for the mass. So how you would do that, of course, well, we need the mole value. All right, so you'd have to calculate it out based on the moles. We'll do an example in a second. Then, of course, once you know the mass, so let's say, for example, okay, the mass I need is 5.00 grams. So then what you would do is you would weigh out the amount that we just calculated, and then you would put it into the volumetric flask. You would then add some solvent to start to dissolve that 5 grams. Now it's important that you actually don't fill it all the way to the top. So here's our volumetric flask. So let's say my 5 grams is in here. You never fill it all the way to the top unless this is fully dissolved. So normally what happens is you add a little bit of your solvent, you mix it around, you ensure that this is fully dissolved, and then once it's dissolved, you then add enough water or solvent to reach the bottom of this line, from the bottom of the meniscus, I should say. So then once that happens, you thoroughly mix it and you have your solution. So you first dissolve in your solvent. Once it's completely dissolved, you top up the flask to the mark on the volumetric, you put a cap on it, and then you basically will ensure that it is mixed. Okay, so here's kind of the process here. So you measure amount of solute, we put the solute inside of the volumetric flask. In this case, the solvent they're using is ethanol. So most of the time, of course, if you're making an aqueous solution, it's going to be water. But the solvent they're using here is just something different. So you put solvent in, you stir this until it's fully dissolved. Once it's fully dissolved, you then add enough solvent to the mark, and then this can be, you put a cap, there's like a cap that comes with this, and then you mix this solution so that it's fully ready to go. So let's take a look at an example. So we have, you've been asked to prepare 250 milliliters of a 0.100 mole per liter solution of NaOH. Determine the mass of the solute you would need to produce this standard solution. Okay, so we have volume, 250 milliliters, but we know we're dealing with molar concentration, so this has to be in liters. The concentration we're given is 0.100 moles per liter, and we know that this is for sodium hydroxide. So we want the mass of sodium hydroxide. So in order to solve for mass, we need the moles. So moles is equal to C times V. Our units are properly done. Remember, this is like moles per liter, right? Times 0.25 liters. So we end up here, so we have 0.1 times 0.25. So we have 0.025 moles that are for that solution. So then to figure out the mass is going to be moles times the molar mass. The molar mass for sodium hydroxide is 1 sodium, 1 oxygen, and 1 hydrogen. So we're going to have here 0.025 moles times, let's get the molar mass here, so 22.99 plus 16 plus 1.01. So this is going to be 40.00 grams per mole times 0.025. So we actually get a mass of 1 gram. So for significant digits, we have 3, and here we have 2. So we need 2 significant digits, so we can do that by simply adding on a 0. All right. So I didn't do too many examples of this because it's very similar. It's kind of pretty much the same calculations as when you did molar concentration, right? So preparing a solution from the stock. So one method, right? You take your solid, you dissolve it in your solvent, and then you have your solution. The other method is using what's called a stock solution. So a stock solution is where you have a solution that is already made. So you have a solution that's made, it just is not the correct concentration from what you want. So it's a pre-existing solution that has a known concentration. So for example, let's say we have HCl and it's 2.5 moles per liter, but what we want is, let's say, 0.1 mole per liter. So like we have this already, but we want a different concentration. So what we can do is we can take the solution we already have and we can dilute it. So this is called a dilution process. So dilution is where you take your stock concentration, so this thing that's already made, and we decrease the concentration, and we do that by adding more solvent. So a lot of times students think of dilution as you're watering something down, right? So you're adding more solvent. So if your solvent is water, you would keep adding more water. But if your solvent is ethanol or benzene or whatever it happens to be, you would just simply add more solvent. So there's a formula for determining how much concentration or volume you have. So we have what's called a dilution equation. So this is where you're working from a stock. So we have concentration times volume is equal to concentration times volume. So the number ones are your initial values. Okay, so usually this is from your stock solution. The C2 and V2 are the numbers from the final. So this is the solution that is desired, or the dilute solution. Okay, now when we're plugging numbers in, you have to remember that the key to this is your units have to be consistent. So it actually does not matter what unit of concentration this is. It can be parts per million, It can be moles per liter. It can be percent weight by volume. Like, it doesn't matter the unit. What matters is the two units have to be the same. So you cannot have one in moles per liter and the other one as percent concentration. They have to be consistent. Or else when you rearrange this formula, your units will not cancel. Same deal for volume. Your volume can be in milliliters or liters or actually any unit, but it has to be consistent. So remember that when we're doing this dilution, you're not changing the moles. So remember, anytime you see the term amount, they're referring to moles. So the moles of your solute are not changing. We're not adding more solute. We're not dissolving more in. All we're doing is we're changing the volume, and by changing the volume, by adding the solvent, we end up changing the concentration. So let's take a look. We'll do a couple of examples. Actually, I'll do one and maybe have you try one. Let me just quickly check. Yeah, so I'll do one and I'll have you try one. Okay, so it has a 200 milliliter solution, 200 milliliters of a 2.40 mole per liter solution of ammonia is diluted by adding 800 milliliters of water. Find the new diluted concentration of ammonia. Okay, so our initial volume is 200 milliliters. So it's like before dilution and after dilution. So this is like before and this is after, right? So before we have a volume of 200 and a concentration of 2.4 moles per liter. Okay, our C2 is actually what we're trying to find. The V2, we are adding 800 milliliters to the original solution. So actually the V2 in this case is going to be 1,000 milliliters because we have our original stock and then we're adding 800 milliliters of solvent. So we have 1,000 milliliters. So our formula is C1V1 is equal to C2V2. We make sure our units are consistent, milliliters and milliliters, so they are. So we have 2.40 moles per liter times 200 milliliters is equal to C2 times 1,000 milliliters. So to isolate for C2, you have to divide by what it's with. Whatever you do to one side, you do to the other side. So our final answer here, it's going to be 2.4 times 200 divided by 1,000, which is 0.48. And remember, the unit that's left over is moles per liter. So here we have one significant digit. So actually, this would round to 0.5 moles per liter. So notice the concentration became less. We went from 2.4 moles per liter to 0.5 moles per liter. The concentration became smaller because we increased the volume of solvent. All right, so this is creating a solution from a pre-existing solution, which we refer to as a stock solution. Okay, so try out this last example. We'll pause the video, and actually I'm going to go into the next part on this. So try out this example, pause the video, try this out, and look at the next part to see how you did.